Alright, what's going on, guys? I'm back with another video. This one's kind of like a continuation of the last video I did, the number 26. Just double check. Leetcode 26. Just so I can show you guys. So I just did the remove duplicates from sorted array. And this time I'm doing remove element. And so basically what you want to do in this question is, here, I'll start with this one. So let's assume that we have the array, this array, and we have val is equal to 2. Basically what we want to do is we want to go through the array and remove all the occurrences of 2 and then return the array. But what's kind of like interesting about how this question is done is it's supposed to be in place. And so because it's in place, like maybe your initial thought would be like, okay, just like start with like the original array. Like let's just say like start with, you could say like new array, and then you can maybe just do like, okay, just loop through like, okay, take the 0, like loop through each value and see if it's 2, and if it's not, add it into the new array. So we would add 1, then we would skip 2, we would add 3, we would skip 0, we would add 4, and then we would skip the last one, and then we could maybe like count the amount of skips, or sorry, we would actually just count like the length and return 5. And the problem with this solution is that it's not in place. So in place means that we only ever actually perform like computations on the array. And so that means that we are not allowed to like create a separate array, or like an extra data structure. So we're only allowed to work with this array, and we have to arrange the values within the array so that we remove all the kind of like occurrences of 3. And so, yeah. So let's get into it. So for this one, same as the last question, we'll use kind of 2 pointers. So right and left, and we'll say, well, r is less than the length of nums. Okay, and then yeah, so I'll just kind of put the code up quickly and then I can explain it. Yeah, and so as you can see, so that's what the code is. And then let me just kind of walk you guys through it, show you how it works. So kind of go through the same way I went through the last one. So we have this, okay, and then I'm going to say L, so L, which is left pointer, is equal to 0, R, which is the right pointer, is also equal to 0. Okay, and then we'll say nums at R equals 0, nums at L equals 0, and then this will be kind of what the array is. Cool. Okay, so what we do is basically we start both the pointers point to the first one. Okay, so they are both point to 0. Okay, and then we'll say if nums at R, okay, let me also just say the val equals, in this case, the value is equal to 2. You can see here, value 2. Okay, so we say, okay, so if nums at R is not equal to the value, okay, we're then going to set nums at L equal to nums at R, increase the left, and then increase the right. And so basically what this does is it does nothing. Okay, and that's kind of like what we want it to do. We don't want to do anything to this first value because we don't want to remove it because it's not our value, right? But so what this is going to do is this is going to increase the right to 1 and the left. Sorry. This is going to increase the left to 1 and the right to 1. So now they're going to go from being both 0 to both 1. Okay. And then, okay, this one's 1. Is that 2? Nope. So now we can go and we can increase this to 2, increase this to 2. Now they both are at the array at 2, so they both point to that. Okay. And so now what you'll see is that nums at r is equal to the value. Okay, nums at r is 2, which is equal to the value. So what do we do now? We skip this. Okay, we only perform this when nums at r is not equal to the value. Okay, and so the point of this is so that we can now continuously increase r, nums at r, until we find the first occurrence that is not equal to the value. Okay, so right now, so nums at r points to here. Okay, so we increase nums at r to 3, which now equals this one, which is still 2. So we increase it to 4. Okay, and now nums at r is equal to 4. Okay, and then we say, is nums at r not equal to value? It is not. So we set nums at l, which is 2, to 4. Okay, and then we increase this to 3. Okay, so now it points to this one. Okay, and then we say, okay, if nums at r is not equal to the value, I'm sorry, okay, so then we increase r. Okay, r is now going to be 5. R is now 5. This was, we were just pointing at, so this is 0, 1, 2, 3, 4, 5. This is nums at r now going to be equal to 0. Okay, nums at l points there, nums at r points there. Okay, we say if nums at r is not equal to value, nums at r is not equal to value, it's equal to 0. Okay, we are then, nums at l is equal to 2. It's pointing at this one. Okay, we are then going to swap this to a 0. Okay, increase this to 4, increase this to 6. Okay, so this is 0, 1, 2, 3, 4, 5, 6. This one, this is not equal to the value. Okay, so we are then going to, what are those zeros? No, okay, this is nums at 6, which is 4, 0, 1, 2, 3, 4, 5, 6. And this is nums at 4, 0, 1, 2, 3, 4. This is 3. Okay, we then swap this to a 4. Oops, I missed this. This is 3. That was there. Okay. We then increase this to 5, this to 7, and then if nums at value is, and then yeah, so we actually don't do anything with that 2 there at the end. We just leave it because that's how we want it. Okay, and then so just double check. So when we print the nums now, as you can see, L is 5, which is what we wanted our output to be. We return L. And the first 5 digits, 1, 2, 3, 4, 5, do not contain any 2s. Okay? And then in case 2, go ahead and copy this. Okay, and nums equals yeah, okay, actually, sorry, so I had it right that first time when I went and changed. I'm not sure why I did that, but yeah, as you can see, that's exactly what we got. Yeah, but anyways, so I'll go ahead, just delete this, submit it. Yeah, okay, so yeah, I hope you guys enjoyed the solution. If you did, leave a like, and I'll see you guys in the next one.